Mighty Cable Company manufactures cable that sells for $120 per meter. For a cable fixed length, the cost of producing a portion of cable varies with its distance from the beginning of the cable. Mighty reports that the cost to produce a portion of cable that is X meters from the beginning of the cable is 6 times the square root of X dollars per meter. Note, profit is defined to be the difference between the amount of money received by the company for selling the cable and the company's cost of producing the cable. A. Find Mighty's profit on the sale of a 25-meter cable.
So for part A, the first thing we are going to do is multiply 25 times 120 because the meter we're producing is 25 meters long and the cable sells for $120 per meter. And the result you get from that is $3,000. Now since we're finding the total profit here, you have to subtract $3,000 from how much it costs to produce the 25-meter cable. And in order to figure that out, you have to solve the integral from 0 to 25. The equation then is 6 times the square root of x, because that is how much it costs to produce a portion of a cable that is x meters from the beginning of the cable. Then, what you do from there is you solve the equation in your TI-89 calculator or TI-84, and you get the value that is $2,500.
B. Using correct units, explain the meaning of the equation 6 times the square root of x integrated from 25 to 30 in the context of this problem.
Now to go about solving part B, you first have to solve the derivative of 25 to 30, which is, in essence, the antiderivative of 30 minus the antiderivative of 25. And in the context of the problem, that means it is the cost to produce a 30-meter cable minus the cost to produce a 25-meter cable. So in essence, the value of this integral is just the cost difference between producing a 30-meter cable and a 25-meter cable.
Write an expression involving an integral that represents Mighty's profit on the sale of a cable that is k meters long.
To go about part C, if you remember how to do part A, it's similar to that. The first step you have to do is find out the total profit you are making and revenue earned on the cable. So it's 120 times k, since each cable makes a profit of $120. Then what you do is you subtract it from the integral of 0 to k, and the equation is 6 times the square root of x dx. Now you do that since the integral represents the cost to produce the cable of a certain length, which here is k. So 120k minus the integral of 0 to k, the equation being 6 times the square root of x, is in essence the total profit earned on any cable.
D. Find the maximum profit that Mighty could earn on the sale of one cable. Justify your answer. Good luck.
Now to go about solving part D, you need to take the answer from part C and find the derivative of it. When you find the derivative of this equation, you get 120 minus 6 radical x. Now the next thing you have to do is set that equation equal to 0 and find the resulting value. When you do that, you get 6 radical x equals 120. Then you get radical x equals 20. And then you get x equals 400. The next step, you write the interval from 0 to 400, since a meter length can't be negative, and then the other interval length is 400 to infinity. The next, you find a number in between the first interval. For here we'll use 1, and for the other interval the value we'll use is 401. The next step, using your calculator, you plug that value into the derivative equation, which here you get 114, which is a positive value, meaning it's increasing, and for the other interval you get negative 0.150, which is a negative value, and it's decreasing. Now, when a value goes from increasing to decreasing, it proves that it's a maximum. Now that we have proved that 400 is a maximum, we plug 400 into the total profit equation. So here it is 120 times 400 minus the integral from 0 to 400, 6 radical x dx. Now, when you plug this equation into your calculator, you get 48,000 minus 32,000, which then results in 16,000. And here, $16,000 is the maximum profit that could be earned on a cable length.
Wow, what a great day to sell cable. Report from the mighty cable company. The cost to produce a portion of cable that is X meters from the beginning of the cable is 6 times the square root of X dollars per meter? Wow, what a great deal! I love my company. The derivative of the function x is defined by s comma of x equals g of x for the interval of negative 4 to 0, and 5 times e to the negative x over 3 minus 3 for the interval of 0 to 4. The graph of the continuous function f prime, shown in the figure above, has x-intercepts at x equals negative 2 and x equals 3 times ln of 5 over 3. The graph of g on the interval of negative 4 to 0 is a semicircle, and f of 0 equals 5. A. For the interval of negative 4 to 4, find all values of x at which the graph of f has a point of inflection. Justify your answer.
For this part, to find the points of inflection, you have to look at the graph of the derivative, which is the graph that is shown, and you have to look for points where the graph changes from increasing to decreasing or decreasing to increasing. On this graph, it changes from decreasing to increasing at x equals negative 2. It changes from increasing to decreasing at x equals 0. Therefore, the points of inflection on this graph are at x equals negative 2 and at x equals 0.
B. Find f of negative 4 and f of 4.
To find f of negative 4, we must first find f of 0, but we know that is equal to 5 because that is given in the problem. Then we must add that to the integral of 0 to negative 4, g of x. The reason why we use an integral is because we are given the graph as a derivative, so we must find the antiderivative of that to find f of negative 4. But because the negative is not on the bottom, we must switch the equation so that 0 is on top. And to do that, we make the integral negative. And to find that integral, we have to look back at the graph and find the area. To find the integral from negative 4 to 0, you have to find the area. From negative 4 to 0, there is a rectangle and there is a semicircle. The area of the rectangle it's a 4 by 2 rectangle, which would mean that the area is equal to 8. For the semicircle, you have to use the equation of area for a circle, which would be pi r squared, but you must divide that by 2. So you get 1/2 pi r squared. The radius in this case would be 2, because the diameter would be 4. And when you plug in 2 for the radius, you get the area to be 2 pi of the semicircle. And you have to subtract the area of the semicircle from the area of the rectangle. So you get 8 minus 2 pi. Once we found that the area is equal to 8 minus 2 pi, we can plug that into the equation. The equation is now 5 minus the 8 minus 2 pi, which becomes 5 minus 8 plus 2 pi. The final answer is 2 pi minus 3. On the board is the equation to find f of 4. You must find f of 0, which is given in the problem as 5. And then you find the integral of 0 to 4 of 5 e to the negative x over 3 minus 3. You use an integral because the graph of the derivative is given, so we must find the antiderivative of that in order to find f of 4. We're going to split up that integral into two separate integrals. The first integral is 0 to 4 of 5 of e to the negative x over 3 minus the integral of 0 to 4 of 3 dx. We're going to focus on the first integral first. We must use u substitution to solve this integral. U is equal to negative x over 3, which makes du equal to negative 1/3 dx. And dx is equal to negative 3 du. Now we must find the new values of the integral. So we do u of 0, which is negative 0 over 3, which is just 0, and u of 4, which is negative 4/3. And now we can establish a new integral, which becomes the integral of 0 to negative 4/3 5 e to the u minus times negative 3 du. And we move the negative 3 to the front. And the integral is still 5 e to the u. Now we're going to solve the integral. So it becomes negative 3 times 5 e to the negative 4/3 minus negative 3 5 e to the 0. The first part becomes negative 15 e to the negative 4/3 plus 15. Now we'll move on to the second integral. This integral solved is just 3x. So you can do f of 4 minus f of 0, which would be 3 times 4 minus 3 times 0, which is 12 minus 0, which equals 12. Now we must subtract 12 from the original integral, and that becomes negative 15 e to the negative 4/3 plus 3. But we can't forget to add the 5 from the original equation to get f of 4. So it becomes negative 15 e to the negative 4/3 plus 3 plus 5, which makes f of 4 equal to negative 15 e to the negative 4/3 plus 8.
C. For the interval of negative 4 to 4, find the value of x at which f has an absolute maximum. Justify your answer.
F has an absolute max at x equals 3 ln 5/3 because this point represents where the graph of the derivative goes from positive to negative. This represents where the graph of the original function crosses from increasing to decreasing. This proves that the point is a max. It is an absolute max because there is only one time that this is the only time that a max exists on that interval.